Good morning, friends. We are learning our subject that is data visualization 3160717. And in that, we are learning the module 1 that is Introduction to Data Visualization. So, we already know that prerequisite of this subject that is working knowledge of programming language, DBMS, JavaScript, HTML4 and HTML5, right? So for that, you already know the things, but still if you do not know, you can see few links are given here, right? So what is there in the syllabus? These are the contents available here. Let us see them. What are the reference books? They are listed here. Fine. So you can see that and you can purchase it or you can try for e-copy download of it. Right? So what contains we want to study for this chapter? That is introduction, data acquisition and visualizing, applications, then key factors of data visualization, and then after exploring the visual data spectrum, right? These are the things we want to study in this particular module. So, introduction to data visualization. So, what is data visualization? Converting raw data to a form that is viewable and understandable to humans. See, it is always preferred that if you show the picture, people can understand well instead of speaking 100 words of the same, right? So the greatest value of a picture is when it forces us to notice what we never expected to see, right? Visualization transforms data into images that effectively and accurately represent information about the data, said by the scholars, researchers, right? So, visualization transforms what? Data into images. For example, if you are having result of your class, from that can we understand how many are having first class, second class, third class? No, we cannot. But if we are representing that using pie chart, you can have the idea. You may not be having the count, exact count, that these many number of students are only having, say, first class or second class or third class, but 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 we will be able to have the idea this many people, that is this many percentage of people are having first class, second class and third class, right? So by using visual elements like charts, graphs, and maps, data visualization tools provide an accessible way to see and understand trends, outliers, and patterns in the data. So, what we have talked of, that is data visualization, right? The grades, student grades we were talking of, right? So, what it does, invisible data to visible interpretation. On seeing the data, we cannot have the interpretation because, say, 60 students' data is there. People cannot have the idea at the time that whether 10 students are having first class or 50 or whatsoever. But if we are having graph, chart, or you can say we are having the visualization of it, we can understand that, right? Let's see. Here say A grade, 14.3 percentage students are having, 4 students, and that one, then say 2 students are having, and 7.1, that is D grade. For C grade, for B grade, how many number of students? That is say 12. How many percentage? That is 42.9. Right? We can understand that very easily because visualization is there. Right? So that is very important in our life. What does visualization do? 3 types of goals of visualization. That is, one is to explore, second is to analyze, and third one is to present. To explore, what to explore? Nothing is known. When the data is there, nothing was known to us, but we have used the data exploration, and we can say that we'll be able to have the detail of it. How to have the detail? That is using analysis, right? That is analyze. Okay, so there are hypotheses, that is always there, isn't it? So what we do for that? To analyze, what for it is useful? That is used for verification or falsification. I analyzed 50% people must be having first class. So I need to verify that. From the data I cannot understand, but if visualization is there, we can understand. But but second step is only to analyze. The third step, that is, you can say, third type of goal, that is present. Everything about the data, and that is used for communication of results. And that we can see pictorially, right? That is what is visualization does. What are the advantages and benefits of good data visualization? So for that, we can say faster action is there. The human brain tends to process visual information far more easily than the written data, right? That is obvious. If I say you cat, cat is a cute animal. It is having 4 legs, 1 tail. It is of, say, brown color, white color. This. But you may not be able to understand. But if I show you the picture of cat and then say 2 ears, 4 legs, then tail, then mustache. So you can understand that very easily because you not only listen to the words, but you see the picture, right? So that you can grab very easily, isn't it? Use of a chart or graph to summarize complex data ensures faster comprehension of relationships than cluttered reports or spreadsheets. Right? It is but obvious pictures, or you can say it's visual presentation. It always makes the effect, isn't it? Communicate findings in constructive ways, right? Constructive ways. See, if it is Excel sheet and you are giving the report, read it, then people will understand it. You can say, yes, ma'am, we can understand. The rows are there, columns are there. Obviously, we can understand that. Yes, But can you interpret that? You cannot, right? So, what should you do if it is communicated in the constructive way, that is, using graphs, charts? Then it can be interpreted easily, isn't it? Understand connections between operations and results. For example, we do have the line graph. Very simple. Let me show you here. Say we do have the line graph. Uh-oh. If your line is, array yaar, line arrow. Yeah. If your line is something like this in the graph, you can say that it is increasing, right? Now this is for say variable x. This is for variable x. Now let me say that one more line is there, and then that is for value y or variable y. Can we see the relationship between these two? This is x and this is y. Can we have the relationship between these two? Definitely we can say that y is having the value that is more than that of x other than for 0, right? At origin, they are at the same place, but after that, they are increasing, and y, that is this one. Whatever variable we are considering, we are not considering the x's, okay? We are considering the variable. Say this is cost, and this is, say, temperature. You can say this is the temperature which is increasing, but cost is increasing more than that, isn't it? So this we can interpret very easily from the graphs, charts, isn't it? So we can have the relationship, or you can say we can have the connections between the operations and results. Embrace emerging trends. Create new discussion. Why to create new discussion? Why to have the emerging trends? See, emerging trends will convince the people that this is something new. This is the current trend, latest trend, and that is the way people are using now. On seeing the visualization of the data, you can create a new discussion. In this particular subject, people are having less marks. So you can say we can start discussion how to motivate people to get good marks. Isn't it? Simple thing. So same way for any business data, if we have created the graph, we can create new discussion. Fine? We can have the machine learning, come one, come all. That is, machine learning is also useful, but we will see that with data visualization. Fine. And we can understand very easily. How you can say yes. Suppose here some data is there, that is there in this green color. What you can say? They are in the same group, isn't it? If they are there in this dark blue color, then you can say they are in that particular group, isn't it? So that is machine learning, isn't it? So for grouping the data, we can show the visualization, and that is one type of machine learning. Fine. So now we want to know a visualization pipeline. So, what is there in that? First is data acquisition. Data are generated or collected. Second is data enhancement, that is, data are processed. The third thing is visualization mapping. That means data are mapped to visual primitives, as for example, colors, geometry, etc. Next one is rendering ND, that is n dimensional to two dimensional. The data is there in the n dimensional, which we will convert to two dimensional, that is the 2D picture. That is a graph, right? Or any other types of visualization. Fine. Okay. So images are generated. Fine. So this is the visualization pipeline. So let us see visualization process in detail. So what do we consider? Acquire. What is that? Obtain the data whether from a file on a disk or a source over network or internet. You can say that you want to represent the data, that is, you can say visualization of the data of, say, Facebook users. Then you should acquire the data from internet, that is from the Facebook to your local disk, and then after you can do the visualization of it. If the data is already downloaded, you can say that it is available on your disk, and you can represent that as the next steps. But first of all, we acquire the data. We parse it. What we do with that? Provide some structure for the data's meaning and order it into categories. So with that, we parse the data. Then you can say we are having filter, that is, remove all but the data of interest, right? That we will keep. Remove all the things we will remove. If we remove all the things, then what will be remaining? What we mean to say is remove the not interesting data, but keep the interesting data. Fine. Okay. Apply methods from statistics or data mining as a way to discern patterns or place the data in mathematical context, right? Represent. Next step is represent. Choose a basic visual model such as bar graph, list, or tree. Then what we do is refine. Improve the basic representation to make it clearer and more visually engaging. Say you have made a graph, but it is not getting clear for interpretation. Then what you do is you are refining that representation. Okay. After that, what is that? That is interact. What is that? Add methods for manipulating the data or controlling what features are visible. So first step we want to know is acquiring and visualizing the data. So for that, the first step in the visualizing data is to load it in our application, right? We have seen the steps here, right? But that was only the steps, and in small we have seen that, right? Now We want to see that in detail. So we want to acquire the data. So typical data sources can be file on disk, stream from network, or digitized signal, right? That is, you can say audio or sensor readings. If stream we consider, we can be considering, say, video is coming, right? Unless you own the data and it is recorded in a definable, digitizable format, things can get messy quickly. How do you process weeks of surveillance video? How does one quantitatively acquire data from an hour long meeting that involved a verbal discussion, drawings on a whiteboard, and note taking done by individual participants, right? Thus, the acquisition stage covers several tasks that sometimes get complicated. What we see, say surveillance video, continuously it is monitoring something. Let us say that these days our government is keeping the videos, cameras, where it is taking the data that whether we have the proper seat belt wearing or not, or you can say whether you have wear the helmet or not, something like that, right? So you can say that from the camera we are capturing the things, and whenever the problem is there, we can say that the bill, memo bill, will be given to them, fine, to that particular person. What I mean to say is the video, or you can say photos, are being captured, the surveillance where it is continuously monitoring who is coming, who is going, what is going on for a particular region, right? So video is that, that's what we have to get it, right, acquire it. Hours long meetings, we can say the lecture is there, or you can say meeting with your class, it may be say hours long. Some drawings can be there on the whiteboard, say while teaching we can be making some drawings and can show you that these things are there, that things are there, how the people have taken the note of it. All these things we need to acquire, and we need to do some steps to get it in proper format, fine. We have to do the process. So what are the acquiring stages? For that, unless you are generating your own data, you have to find a good source for the data you want. I want to have the data in, say, JPG format and in the size that should be 10K only. Then is it possible that I am having the data set in the same way? I may not be. So I need to transform the data in the manner I want to have it, right? So what it says, unless you are generating your own data, whatever data set you are having, but you transform it in the format which is useful to you, right? If you don't own the data, you have to make sure you have the right to use it. If we do not have the right, we cannot use it, isn't it? You may have to go through contortions to extract the data from a web page or other source that wasn't set up to make it easy for your application. You have to download the data, which may present difficulties if the volume is large, especially if it is fast changing. You can say if you download the data from Facebook, it is continuously coming. But is it changing continuously? No. It is only adding the data. It may be the case that where the data is being changing. So at that time, it will be difficult for us to get that data and that to be in consistent manner, right? By following techniques, data are converted to proper format, and they are, say, modulation and sampling, digitization and coding, and we need to consider the file formats. Data can be shared using non-standard text files or existing standards, that is CSV, comma separated values, XML, that is extended markup language, ANIML, that is one more markup language, right? So we can say that we have considered the acquisition or acquiring of data. Fine.